Hi, we are group 404 and we have 4 team members. I'm Shiki Lei and I will take care of the introduction of our project.
I'm Yue Zhang. I'll lead you through how our project works.
I'm Han Xiaochen. I will describe the data science and machine learning part.
I'm Tong Xin, and I will take care of the conclusion part.
Okay, let's dive into the introduction. Our project name is Natural Disaster Detector. So for every year we can see that natural and human-induced disasters cause enormous infrastructural damages, monetary losses, injuries, and even deaths. In June 2018, wildfire happened in California, affect thousands of families. People lost their homes and millions of dollars were spent on operations by government. Unfortunately, climate change is strengthening the destructive power of our natural disasters. So, in this context, our goal for this project is to use natural disaster detector to used by the Earth Observatory Natural Event Tracker, aka EONET, to track entire globe daily and provide a visualization of our natural events such as wildfires, storms, and sea lake ice. Basically, we divide our event into two categories. One event is the event that are happening right now, and another is the event that already happened within a year. And yeah, so this part Yue will take care. And another goal for our project is to build a prediction tool named our disaster alarm. It used to forecast the probability of natural disaster occurrence, and it can be used to explore the wildfire rate in two cities, Seattle and Los Angeles, based on weather and temperature of selected area using our dark sky API as shown in the visualization, and Hanxiao will also take care of this part. So for our data source, our natural disaster detector utilizes near real-time natural events occurrence data from EONET, and our weather data are from dark sky. And so for our data set, we got updated every 5 minutes, and our data source were updated 4 times a day for EONET. And one thing you might need to pay attention is that please do not leave the detector open for the whole day, since if number of inquiries is over 1,000 times each day, the dark sky API will charge our teammate Hanxiao's credit card. Okay, so let's welcome Yue to talk about how our project is started.
Yeah, so here is our GitHub page, and we will use Gitpod. Let's wait a minute. Take some time.
Yep.
Okay, it's initializing. I will first show you the requirements.txt and the YAML file. Yeah, now the port for MongoDB is available here. Actually, in our project, we have one database with 2 collections in MongoDB. Yeah, they are called disasters and the weather. And data acquire, we use 2 URLs, like 2 APIs to get both data. And we have the logging working to record what we are doing. Yeah, now we have the website available. We have an error here, but it's not a big mistake. It's just because our data has not yet been prepared. So now we have observed the MongoDB database for disasters. We have about 4,000 rows of closed disasters, which means the disaster has ended, and about 400 rows for happening disasters. I will show you, this is how our data looks like. We have the location for the disaster, the time, and the type of the disaster. And now it's grabbing data for the weather. We used weather for the past month and the weather forecast for the next week. We started in the weather collection, and here is how it looks. We have multiple data for the weather. Includes the temperature, the wind speed, and others, and also the date. So let's refresh. Now it works. So I will lead you through the disaster visualization part. We have a checkbox here. It says open and closed. For open, it means the disaster is happening now, and for closed, it means the disaster has ended. We also can choose the disaster kind. We focuses on 3 disasters, means wildfires, severe storms, and sea and lake ice. Those 3 disasters are closely related to the weather information. And we can see that wildfire happens a lot in California, and it's still happening a lot now. Yep, and for severe storms, it's not happening a lot now, but it's just happening a lot near the equator. And for sea and lake ice, it's happening a lot these days in the South Pole. So actually, in California, wildfire has been a big issue. So in the next part, we will let Han Xiao talk about how we would like to dig into the wildfire.
Wildfire is a major disaster on the west coast of the United States. So in this study, we focus on the impact of wildfire on the 2 cities from the west coast, Los Angeles and Seattle. Intuitively, if a wildfire is distant to a city, then its influence on the city will be very little. And this idea is very similar to kernel density estimation, which assign more weights to the neighborhood of a point. And the input of our kernel density estimator is an array of 3 dimensions, which include information of latitude, longitude, and date. A parameter of kernel density estimator is called bandwidth, which is alarm rate in our page. And alarm rate means the region that affected by a disaster. The disaster become more influential if the alarm rate become greater. And high temperature is an important feature that we identified by applying random forest. The pink line means real wildfire rate, and we calculate by using kernel density estimation. The right line is our predicted wildfire rate, and we compute it by using random forest. In our EDA part, we firstly pre-process the data and clean the data. For example, we read the data into a data frame, convert strings into dates, and make a time series about it. Then we apply kernel regression to capture the long-term trend, seasonality, and the residuals. The blue dots here represent our raw data, and the red line is our regression. If you look at the peaks of the raw data, you could observe that there is an ascending trend. Then we subtract our regression values from the raw data and get the residuals. After that, we calculate the exponentially weighted moving standard deviation and plot it. You can observe that there is a ascending trend in the variance of the noise. Then we use empirical mode decomposition, which is a signal processing method. This method can divide a time series into several curves of different frequencies. For example, IMF1 here represents the curve with highest frequency, and IMF8 here represents the curve with lowest frequency. So IMF8 is the long-term trend, and the sum of IMF5, 6, 7 is the seasonality. You see there is a seasonality of the period of 1 year. The sum of IMF 1, 2, 3, and 4 is the noise in the data. So again, we plot the noise and calculate the exponentially weighted moving standard deviation. There is also ascending trend in the variance of the noise, and this plot is actually very similar to what we get in the regression part. So our results shows that there is an increase in the variance of the noise. This means that there will be more difficulties and uncertainties in our prediction.
As we have went through the motivation behind our project, how we collected and processed the data, as well as the data visualization and enhancement parts, I will go over the software component architecture in case anyone is interested in reproducing this project. Also, I will talk about the possible next steps for our projects. Also, bear with me for the snoring of my dog. Sorry for that. So first, let's go over the project architecture. Our project uses MongoDB as the database, which that is where we store all our raw data as well as the updated data. Or data acquired are stored in raw form to the database. An abstract layer is built in database.py so that all the queries can be done via functional call. For more complicated app, the layer will also be responsible for schema consistency. We have plot.ly as well as dash app to serve this web page through. Actions on responsive components on the page is redirected to app.py, which will then update certain components on this page. So after I talked about the project architecture, we will go over the possible next steps for our project. So there are basically two parts. The first part is about the disaster visualization part. As we can see right now, we have 3 natural disasters showed in our map. So we are also interested in adding more natural disasters to our map so that people who are more concerned with other natural disasters can also utilize our website. Also, as we can see right now, all the points showing the locations are actually using the coordinates. So it's kind of hard for people to tell which city or which country the natural disaster is happening. So our next step also includes adding city names as well as country names to our map. So besides adding more natural disasters as well as the locations to our map, we are also planning enrich our prediction parts. So as you can see right now, we have 2 cities listed. One is Los Angeles and another one is Seattle. So we are planning to add more cities such as Beijing, Shanghai, Xi'an, Tianjin, or even Boston, because these are the locations where our team members are from, also where we lived right now. So besides adding more cities, we are also considering adding more natural disasters, which has the prediction alarming, so that maybe the users of our website could see the alarmings for other natural disasters if they are interested in that. Okay, so these are the possible steps for our project.
So thank you everyone for listening our project, and that's it for our project. We hope you enjoyed it and you can play with it. Thanks.
Good.
Thank you.
Thank you.
Thank you. Merry Christmas, guys.
Merry Christmas.